and linker followed by the phases of the compiler. So we'll start our discussions on the loader part. We have already discussed on the concepts of assembler, the concept of macro processor. Are you able to hear me? Can I have some response from your end, please? Okay. Thank you, Ma. So we'll start with loader and linker. Uh, if you remember, we have just gone through and gist of it in the previous year, the last calendar year. We'll just go through, recollect what it is, and then we'll move ahead. Loading and linking sometimes go together. So as such, there are three main functionalities which we have to keep in mind, which can be combined to have three different forms. So the three functionalities are loading. The first one is loading, which means you translate the program or you take the program from the secondary memory, secondary storage device, and place it onto the main memory for execution. What do? We do a lot of address translation. We take them from the secondary storage device where it is stored, and then we move those to the place which is allotted in the main memory by the operating system to our program for execution. And sometimes we need to do a lot of relocation. When relocation happens, most probably when there is an instruction which refers to another instruction which is saved at a particular memory location. For example, the instructions such as load accumulator content from the memory, or you jump on to particular instruction, you jump on conditionally, you jump on unconditionally, so on and so forth. So a lot of relocation has to happen. And the last one is it's not enough that only one program is always executed. We can always link two or more programs and then do our execution. Then go ahead with our execution. So these are the three main functionalities. If we are doing loading alone, if there is no address translation process is required, you call it as obsolete loader. Most probably these programs doesn't have instructions which points on to a particular instruction at a later point of time, and therefore no address translation is further required. You call it as obsolete loader. If a address translation is required, both address translation has to happen as well as it has to be loaded onto the main memory, and then you call it as loader. And the last one is linker as such. If you can combine two or more programs, refer them and start your execution, then you need a linker. Now, if all these three functionalities are together, then you call it as linking loader. Having said that, we know what an obsolete loader is. We don't do address translation, but then we do the translation of replacing the program from, or taking the program from the main secondary storage device and putting it onto the main memory. Now, what are we supposed to do in the obsolete loader? Any machine language program has three types of data in it. With the help of the informations what we have learned in yesterday's class, the machine language program will be represented or assembly language program will be converted to a machine language program, where the first one is the header H. Header H followed by the name of the program, the starting address of the program, and the length of the program, and followed by the other set of lines which starts with T, gives in the starting address, and followed by the set of instructions, and then the next address followed by the sequence of instructions. And then 2039 is the data where you are supposed, which we have stored in, and E represents the end of the program, along with the starting address of the program, which is optional. So this is how the information has been stored. Now in this case, if there is no change, you are just taking it from one position and placing it onto the other position. So what really happens is you have the header program, you have the text. Now here you have an example. We have minimized the machine language code. You have an header, the starting address along with the length of the program. And then you have T space instead of caps. I am giving a space here. The starting address followed by the set of instructions. And then you have T, this 2000 stores in the data information, the data which is required for executing your program, followed by the set of information. And at the end, you have E. Now what happens here? We are supposed to store it or load it onto 3000H. So what happens? Every instruction is represented by a word which is 24 bits or 3 bytes. So 3000 we'll have the first two, the opcode of the first instruction 14, 3001 we'll have 20 to be stored in, 3002 we have 33. So this first set is been split into 3 and it is given in 3 different bytes. And again followed by 3003, 4, 5, and 6, 4 and 5. Then you have 6, 7, and 8. Here we stop. We stop with 2036. And then we start with the data. Data will not be loaded onto the main memory. It will be transferred to the registers as and when it is required. So we will not load the data onto the main memory, and therefore there is no change in the location where we have stored in the data. Only change is with the program. The rest remains the same. So you have an algorithm for absolute loader. You try to read the header, check the program name and its length, the starting address and its length, till you have the record type. So what should I do? I should not do anything with the header data. But then I have to do something with the text record and not with the end record. So you have header, text, and end. We are not going to do anything with header. You try to solve everything in your text record, and then this will proceed or we'll iterate it till you reach the end record. And so if the record type is not E, you just check if the object code is in character form. If it's required, you have to convert it into an internal form. Illana, what you'll do is move the object code to the specified location in the memory and you start reading the next record. Check if the record is E. If it's E, you are supposed to move out. Illana, until you read the end record, you are supposed to move each and every byte onto the specified memory location. Now you also have 1 and 4. Now this occupies the bytes. As such, you will be able to convert it into 2 different information. So now what happens? 14 as such is 2 bytes in the object program. So to make it a single byte, we'll have it as hexadecimal value 14 because you need only 1 byte. Normally, if I represent 1 separately and 4 separately, 1 has to be represented as an 1 byte, 4 has to be represented as another byte. So 14 has to be represented with the help of 2 bytes. But then opcode for us requires only an 8-bit information, which is any opcode given requires only 1 byte of information. And therefore, we take 14 as an hexadecimal value and try to present it so that it occupies an 1 byte. Now it is simple and efficient. You have to do a lot of work if an address translation is required, because absolute loader has no job in performing the address translation amongst the instructions. It just moves in the data from the secondary storage device to the main memory. So what we do is an additional manual work has to happen if the instructions points to the address of various other instructions. And since you cannot do and control flow, it is also difficult for us to work out with the subroutine libraries. Now we'll go in for something called as a bootstrap loader. What is bootstrap loader all about? As soon as we switch on the system, certain processes starts executing by itself. We don't inform it, we don't load it, and so on and so forth. So what happens as soon as you switch it on, information which are stored in the secondary storage device, certain informations are pushed back onto your main memory and it starts executing. And only then you say system boots up, and then required application starts executing, so on and so forth. Now, if you really understand the microprocessor concept, way in which you type in the program and where you type in the program, your faculty would have told you that you start typing in the instructions, for example, from 1000H and the data from 2000H. Now, what happens to the memory location from 0 to 1000? That is a question which we have to answer about. Now, Bootstrap loader takes in certain system softwares, place it on to the memory for execution. It doesn't give any allotted space. So what happens? A set of memory location will be allocated for processing. So you have a little bit of memory location which is allocated where you will be able to push in the bootstrap loader so that it can load the required application and start its execution. And therefore, we start inserting our instructions only at a particular memory location and not before that, because it is solely for the only purpose of doing all this bootstrap things and something which is related to the memory and the main processes which works behind the screen. So now what happens? You try to get in the address. And then you have to convert every of the character into an hexadecimal value, and therefore you use getC to get it. And you have, if there are more informations, you will save the first 4 bits of yes, higher order bits of yes, and then again you getC, do some addition out of it and convert it. This is all a conversion where you try to convert an given value onto an hexadecimal value. Now you read one character. If it's less than 48, you know how it happens. These translations happen. And if it's less than 10, you are supposed to do a little bit of other translation. So that is what getC happens, performs. So now we have the bootstrap loader. Now there are different loaders as such when combined with the linkers. So you have 2 different varieties of linker. One is the linking loader and the other one is the linkage editor. Now, what is the difference between these two? We'll be able to visualize it with the help of this diagram. Now, linking loader links all the program and gives it to the memory, whereas linkage editor links the program, gives a new linked program in case if I have to connect with 2 different programs for execution. It directly links it and gives it to the memory. Now you have an output of linked program in your linkage editor. Only then the address translation happens and then you move on to the memory. So that is the difference between a linking loader and the linkage editor. So it performs all linking and relocation operation and directly stores into the memory for execution. It also performs relocation. Fine. So, but then what happens? It performs linking, it performs relocation, it also loads the program into the memory for execution. What about linkage editor? It does it in 2 phases. First, you produce the linked program as output. So what happens? The linkage editor performs relocation of all control sections relative to the linked program. Once that is done, you go ahead with the address translation and you store it. Fine. Now, which one is suitable for usage? Linking and relocation and loading, if it goes hand in hand at a stretch, every time when the program is executed, you have to do all these process. You have to link it, you have to reload it, and then you have to load it and execute it. Whereas in a linkage editor, you can link it and keep it as an object program. And once it is required, that object program can be executed. So if you require more time of execution, this linkage editor performs better because it gives you an output. That output can be used for execution, whereas linkage editor is not, linkage loader is not so. It goes hand in hand. So you link it, you do the address translation, you load it, and then you execute it. So if you go on editing a program, you are supposed to check in various test conditions, you do development of a program. In that case, linking loader works because every time you do a little bit of change in your program, you try to compile it, link it with other programs, try executing it, and check whether it works for all the test cases, so on and so forth. And therefore, a linking and loader is much appropriate. Whereas linker editor, if you have a developed program, a program which is test for all test cases, you can always use an linkage editor which will pull out all the required libraries, all the required programs, combine it as one package or one object program as such, and you can load it when as and when it's required for execution. So that is all about your program loader and linker as such. If you have any clarifications, you can ask me now. Else, you can just raise your hand so that we'll move on to the next topic. Okay, thank you. Fine. So we have come to the end of the system software part, where we have talked about assembler, we have talked about loader, we have talked about macro processor, so on and so forth. Now we'll start with the phases of the compiler. But then before I start with the phases of the compiler, you also have to understand or pull out all the software, system softwares, what you use as a language processing system. Operating system does something behind the screen. It allocates memory, it does a lot of IO device handling, so on and so forth. But then what about a program, a language processing system, or a set of software which helps you to translate the program what you have typed in? So you have the source program, a preprocessor provides you the modified source program in the same high-level language. And then we have compiler, which either gives you an assembly language program, or certain compilers provide you the output as relocatable machine code. So the output of a compiler can be any one of these two. Either it can be an assembly program or it can be a relocatable machine code. So what happens? You have an assembly program. If the output is an assembly program, assembler plays a very important role. And if you have a relocatable machine language program, you go ahead with the linker loader, and then you have the target on the absolute machine language program. So you have, what is the output of compiler? Output of compiler would be relocatable machine language or relocatable machine code or assembly code. What is the output of a loader? It is obsolete machine code or the target machine code. Fine. So this is all a nutshell of what you have learned. You have learned about assembler, You have learned what an compiler is. Fine. And then we'll try to do a analysis on the it is another kind of, again, another language processor which tries to execute it line by line. And so the machine the target program which is provided by compiler is relatively faster, because interpreter always maps it with the help of input and output. So for error diagnostic, for you to debug your program, interpreter would be much preferred. But for execution by a point of concern, compiler would be much preferred. The simple reason is interpreter does it line by line, maps it to the given input, and tries to produce the correct output. Whereas the compiler takes the whole program as such, does a lot of analysis and gives you the answer. Fine. So that is about the compiler and the interpreter. We also have something called as the, once again. Okay. We also have something called as cross compiler. Let me put it onto the screen. You have, we'll put it onto the chat box. We'll have cross compiler. Now, what is this cross compiler all about? A normal compiler, if it is executed, it converts a program pertaining to a particular processor. If I am using i7 processor in my system and I compile a C++ program, it gets converted to a machine language which is supported by the i7 processor. Right? That is normal what a compiler normally does. But then I have an i7 processor and someone has an M1 processor. And I have a compiler which takes in the C++ program, compiles it, and produces a machine code which is which is uh, which is for your M1 processor. Then you call it as a cross compiler. So a compiler which produces a machine code for another processor other than its host processor, you call it as cross compiler. Fine. So with this information, we'll just jump on to the phases of lexical analyzer. No, but before moving on to the phases of lexical analyzer, let me put it in very easy perspective. What does compiler do? Compiler performs a bit of translation. Okay, what does compiler do? Compiler performs a bit of translation. What translation does it perform? It translates the program in one language to another language. Have we done translation? We have done a lot of translation. I hope you remember what I have told you in earlier classes. If I would have got a document in any language and you are asked to translate it into some other language, what do? I first analyze the given input document. What do I analyze it for? I ensure that the document has to be correct in terms of spellings, in terms of grammar, in terms of meaning. So what three things do I analyze it for? That document which is handed over to me should be error-free. Error-free in terms of spellings, I'll repeat, in terms of grammar and in terms of the logical meaning. I cannot translate an incoherent document into another language. That's quite impossible and that's not required. So what happens when there is an error? You try to analyze it. Either you rectify it or you call the person who has given you the document and say that these are the errors which I have found in the document. Please do rectify it. Now, how many errors have I told you? I have given you three different type of errors. One is lexical, one is spelling error, the other one is grammatical error, and the last one is logical error. The same three analysis happens in the first phase of your compiler. The compiler tries to analyze the input program for various errors, right? So what do I search it for? We'll go ahead with step by step. I will, one second. Okay. Now, the first one is spelling errors is what we were talking about. Now, this spelling errors can be mapped with the lexical errors what I have in the program. This is just an analogy of how you do the documentation and how you do the conversion. So spelling errors in our normal document can be mapped with the lexical errors what you have in your program. What is this lexical error all about? Sometimes by mistake, I haven't defined a variable. Now you don't go ahead with your Python programming, okay? Go ahead with Java, go ahead with C++, C#, and so on, where you have to declare those variables. So if I haven't declared a variable by mistake, you will have an error message saying undefined variable. Why? I haven't declared that variable as an integer or as an float or double or as a character or as a string or as a class instance. I haven't done anything with that variable. So it gives you an error message saying, hey, there is a variable which is undefined. So you have an undefined variable. Sometimes by mistake, this happens mostly with when you use C. And that is what I have found out. If you have similar experiences, you can tell me. Sometimes I use C for count. And if I use character in the program, I use C for say the same C as in character. So how many declarations have I given? Somewhere at the starting of the program, I thought that a character has to be assigned and I have said C as in character. And somewhere down, I thought a count has to be added. So easy way of, instead of typing count, I said int C. Now what has happened? I have given two declarations for the same variable. One is a character and the other one is an integer. Which one should the compiler take in? It throws out another error message saying there is multiple declaration. Fine. So these type of errors are termed as lexical errors. And then comes here grammatical errors. Grammatical errors are mapped with the errors in your syntax. Sometimes we would have missed out a semicolon. Sometimes we would have missed out an equal to. Sometimes you would have missed out some other operator, so on and so forth. So what has happened? You have missed out certain thing and you haven't followed the syntax of your ESMA.
The screen is not.
Oh, okay. I'll share it. You go in for the difference of the errors in the syntax. Sometimes by mistake we would have taken in we are used to certain syntax of certain programming language, and when you type a program in another programming language, you use that syntax of the programming language which you are familiar with, and you end up in a syntax error. So the next phase, once you check the lexical errors, the next phase is to check whether your program is syntactically correct. It is correct with no syntax errors in it. And the common mistake, what we all do, is the unbalanced parenthesis. We would have added sometimes a parenthesis on top, and we would have missed out in the middle. We would haven't added a parenthesis on top, but then we would have given a new parenthesis at the end, and therefore we end up in unbalanced parenthesis. So all these are syntax errors. Now the next one is you ensure that your document is logically correct. What does it all mean? Logically correct, it has to give you a coherent meaning. What does giving a coherent meaning mean in terms of your programming perspective? For example, you have A as an integer and b as an integer. You can add it, and this is allowed, right? You have a as an integer, b as an integer. Addition of two integers is allowed. Whereas if I have a as an integer, c as an character, you end up in a data type mismatch error. Why is it so? Because they are not compatible. It doesn't give you a meaning. Sometimes we assign a string to an character, it throws out an error. Sometimes during conversion of pointers, address values, it throws out an error. Fine. So sometimes it checks this phase, checks for the compatibility of data types of the given expressions. And for example, if you say if A is less than B, if statement has to have a logical expression, relational expression, which evaluates to an Boolean value. Instead of that, if I say if A and A is not Boolean, okay, if A plus B, then you have an error message which pops out because it is not syntactically correct. And it doesn't give you a logical meaning. And therefore, you have a logical error. And this logical error, we call it as the semantic error. So the first job of the compiler is to analyze all your complete program and to find out whether these programs whether the programs have the specified set of errors. If not, what next? So this you do a thorough analysis of your program and say there are no errors found, or it says there are errors found and then stops. It doesn't go for execution. It points out all the errors. Sometimes it's not errors, but then warnings because there will be loss of data when those expressions are being solved. We'll talk about all these in detail. But as of now, the compiler analyzes all the three type of errors. Now your program is error free. What should I do next? I convert it into an intermediate code. Why do I convert it into an intermediate code? It's very simple. You have a very lengthy program, or you have a very lengthy statement. Sometimes when we learn, we tend to read a paragraph, and the paragraph is more than 10 lines, we get very annoyed. And if I have, for a particular topic, for example, if I have a book and the topic runs through 5 pages, 5 pages of the book, and I have a PPT which runs through 20 slides, and I have my friend's notes, which is shortened for only 1 page. Which do I prefer? I'll have you have 3 options. You can post it onto the chat. The first option is for a particular topic, I have a book with 20 pages, 5 pages, which I have to read through. And the second option is I'll have a PPT maybe from 15 to 20 slides. And the last option is I have a friend who has concised everything to 1 page. Which one do I prefer? One is book, two is slide, and the third one is the friend's short notes. Can I have the answers on the chat box, please? Okay, can I go for a poll? Just wait a minute. Okay. You have the poll onto this, which is posted. You can now give your answers. There are a lot of good students here. I just have received 35 votes, which means the rest. Okay, we have votes closed around 50. Let me end the poll. If you want, you can just vote it. Now, as such, as expected, among 50 votes, I think 26 have voted for one page of notes which your friends provide. The other 15 have said that we learn it from the book. So, what the smart way of learning is you go ahead with one page of notes because that gives you a concise information. It's easy to understand rather than with all the explanations, complex value informations, a lot of complex examples, and so on and so forth. So we are confined to the smaller version. Yeah, and now the other way of doing it. A movie which runs around 2.5 hours. What some of us don't have the habit of looking into it. What do we really do? We ask a friend of ours who gives you some input on what you have seen for 2.5 hours. Some of us even don't sit throughout the game sports tournament for a day or for 5 hours or 6 hours. We just watch only highlights. Okay, so there are a lot of people who does a lot of version. But now I'll ask you another question. I have a sentence which runs for 5 lines, a single sentence. If it goes for 5 lines, to stop where it is required, to understand, to split them into different subparts, and to understand it is quite tedious. So what we normally do, we break them into smaller sentences so that I'll be able to understand it. And you put it in a perspective where many of us can understand. And therefore, the next step of the conversion is intermediate code generation. And this is where bytecode took a leap. It said the intermediate code which can be generated can be taken and executed in any processor, and therefore it is platform independent. And so you have intermediate code generation, which is a format which doesn't depend on your programming language, neither it doesn't depend on the processor. For me to check whether there are any errors, the compiler has to have the knowledge of the programming language which you are working on. So if it is a C compiler, and therefore we say that is a C compiler, it is a C++ compiler, and so on and so forth. The simple reason is if I give it for a C compiler, it checks for the syntax based on the C programming language and certain constraints constructs based on the programming language C. And therefore, you have, for the analysis part, I have to really have an understanding of how the programming languages, and then you convert it. You have to have an understanding because we should know what those does. And once this is done, the next one is an optional phase, which you call it as code optimization. Okay, you do a lot of code optimization to it. How do I optimize it? Suppose I have spoken in for 15 minutes, I have taken a class for 15 minutes. Certain concepts I would have reiterated it. certain concepts I would have given you additional examples for which for some of you it's not required. So what you do, you take those 50 minutes instead of taking 50 listening for a 50-hour class. Some of us go for concept videos. Am I right? Now, what is that all about? I don't give an extra explanation. If you need an extra explanation, you replay it and I understand what it is. But then I'll just tell what the concept is all about in just about 4 minutes, 5 minutes. So what happens? You have concised it into very small amount and with the information in smaller parts, and it is easy for you to understand, but it also serves the same purpose. So instead of reiterating it 10 times, I am just saying it once, and if required, you replay it. That's it. So now what you do, a bigger expression would be converted into a smaller expression. And then you also check if there are any redundancy. You have code optimization, which happens in your intermediate code level as well as in an assembly language level. We'll talk about those two in module 5 when you talk about module 6, when you talk about code optimization. So you try to reduce the number of instructions. You convert the instructions in a different format, so you get an optimized result. And the last one is code generation. The last one is code generation, where we try to understand what the code is, understand the assembly language program or the intermediate language, convert it into your machine code. Fine. So all these has its own cost. Now with this information, we'll move on to the next part. So you now convert the type of program for lexical errors. Let me just put it for lexical errors. Analyzing the lexical errors, you have something called as lexical analysis. For checking whether the program is syntactically correct, you have something called as syntactic analysis or syntax analysis. And then if it is for this one, checking whether it is logically correct, you have semantic analysis. All these three phases of the compiler put together, you call it as analysis phase. You completely analyze the program, and below that you have lexical analysis, syntax analysis, semantic analysis. Take all together and you ensure that you have the lexical analysis phase. And then you have the synthesis analysis, synthesis phase, where you do the code generation, you do code optimization. Here code optimization is given at the end, because you analyze, you get the assembly language program and then optimize it. This can be done after assembly language program or after your intermediate code generation. Fine. So this is all the overall structure of the compiler. Here you have along with the output of each and every phase. We'll stop here. We'll talk about the output of each and every phase in the next class. If you have any clarifications, you can ask me, or else we'll wind it up.